So it's good. A little older, it degraded, it degraded over a period of time, and now we reset a new very standard. Sort of like what we've done with our educational system. You can't get A's, we'll like lower the grading thing. And that's truly what it is right now. All right? So degradation programs never, once they're in a computer, they're in there forever. If you change the computer trying to get just this, whatever reason you have to change it, say, I don't want the degradation program, I'm going to change this computer. Computer wakes up and goes, oh, whoa, I'm in a brand new car at Detroit. And I go, where the hell am I? The hell, I'm in an old Chevy? What's the miles? Boop, degradation program kicks in. You know, so you just waste your money. But you got to be aware of this point. You can't test a 20,000-mile car like you do a 120,000-mile car. You got to give it something. Yes, sir.
When you program the ECMs, the mileage automatically compensates with that program?
Yes, because it sees the odometer.
Right.
Yes.
So it syncs up, right?
Syncs out, yeah, I'll go with that. Syncs up. And I'm just dashing ahead here because... So here's fuel cells. Why wouldn't I use Bernie's? It's his program has better. So we're going to go off RPM and engine load there. And when we look at fuel cells, some people say, well, long-term was good. I go, when? And then there's a pause, and I realize they didn't look in every fuel cell. If you have an E-scan, you see this. If you don't have an E-scan, how are you going to see every fuel cell? You got to graft long-term fuel trim and then drive the car through the fuel cells. You got to start out, and don't be whacking the throttle, smoking the tires, you know. So what you got to do is drive the car normally to heavy load and then back down again, and then fill the squares on his computer. What you're going to look at is grafting, and then you can bring your play the frame back, and see what the actual long-term value is in any given cell. Right here, what happened? We were at all under 5, and then when we needed fuel, we got what? Some type of correction. When we got this correction going here, this is above 5 but below 10, so it's that factor. This is the modifiers, guys. This is the modifier. This is when you go after the fuel enrichment, the modifier. This is when you do those tests we were talking about. Here, rut roll, when we need the most fuel, we don't get it. This is a dirty fuel filter and any version of that you want to add. Is this a crankshaft position sensor? No, the crankshaft position works good slow, it works good fast. Right? Okay, I know it's late, so I don't expect an answer. So this is cool because everything I say from here is gold. Some cars, if you have a factory scan tool, you can see the purge cell values, but just don't pretend you can do anything with it. We can't really, we don't know how to test it because we don't know what it's doing there. Here, this is absolutely a dirty fuel filter. This is absolutely every variation of that. This could be a fuel pump that works good when we're not asking a lot of it. It could be we ask too much of it. When you look at this is out of a real car. I know it's a drawing, but it's out of real cars. This is usually a dirty mass airflow sensor. And what you see, the pattern you see, is actually the negative values in long-term fuel trim at idle, and then they kind of get somewhat normal, and then they go bad. That's a dirty mass airflow sensor. 175 millon dirty mass air. So any question about dirty mass? Clean, dirty. What's the one thing you've got to do if you have a dirty MAF? You have to test and someone screamed out at the top of their lungs, the burn-off cycle. If you don't test the burn-off circuit, it's going to get what again? No, we got it. All right. So this is an example of a bad input. Here's a bad input that works good some of the time and it's got an intermittent problem. Right? It's some situation, it's some condition, it's not giving the computer correct information. On speed density systems, the fuel cells look very linear. On a mass airflow, they're kind of helter-skelter there. So what was that first one? It was a speed density, Mike, right? That's right. So you know, when you see this, if it's just say accidentally you worked on 35 speed density systems. The first time you started using fuel cell, you worked on 35 speed density. You would think this is normal because it's very linear looking. And if you saw that, you'd think it's bad. Wait a minute, it could be, because when would this be bad? When you're on a speed density system, right? This is what a speed density system looks like. It's sort of very linear. Here's what a mass airflow. It's kind of helter-skelter there, right? So when you look at this, when driving, the engine doesn't stay in these fuel cells for very long, so you got to be kind of understanding it's going to be a little erratic. But look at this. Look at this. What the hell is this? What's the thing you most notice about it? It's all over the place, but what's the most...
When it's bad, it's always clean. Well, it's actually very rich, it's taking fuel away.
Yeah, and I want you to notice something else, because I said it twice now, and that just because I said it twice doesn't mean you're going to remember it. That's why the very first slide had my email, so you can ask me questions anytime you want. But the truth is, what I find out about these are the zeros. It's never perfect. Sometimes it's perfect, sometimes it's horrible. Sounds like a hooker I knew.
Very well.
I get to G's house last night. I'm going to sleep there last night. Remote doesn't work. That's it. I'm ordering a hooker. No, not what you think. I just had her stand beside the TV and change the channel. All right? Let me just go back to that. You see what I see? Am I running rich? Am I running lean? That's too screwy. That's too screwy, you know? I'm going to clear those. When I can't make sense of it, I'm pretty sure the computer can't make sense of it. But the thing is, I'm the guy I got to please. We talked about who we're going to please. I got to please me. And if I can't make sense of something, I clear it and start it again and watch it learn. Computers learn real quick now. It's not like an OBD1 where you got to clear it on Tuesday and wait till Thursday for it to learn. You know, it's not like that. They happen fast now. You got to add total fuel trim, so you got to add your rear fuel trims. This is a Hickok unit on a Ford. So if you have rear trims, you got to understand that you can add them. And the truth is, if your scan tool doesn't give you rear fuel trims, there's the answer. Too bad, but you got to compensate a little bit. The system's still going to use it whether you like it or not. So you got to understand, when you see fuel trims and you don't see total fuel trim, or you don't have a PID total fuel trim, if you don't have a PID for rear fuel trims, then what you got to do is add a little something. And I kind of add 2, 3, 4. That's what I add, because it's never really huge back there. So I'll say, you know what? I got everything near. No, I got every long-term value on my car is 5. Good or bad according to my specs. Good. But if I add 3 to 4 to something, now what is it? It's into that questionable part, and I'm all over the modifiers like stink on poo. Questions on that? Questions at all? Let's just get a little EGR and I'll let you go. You know there's 1,000 EGR codes. At least there's 5. And it all breaks down to insufficient flow, excessive flow, and the control circuits of the devices are bad. Am I there? Yeah. All right. Does this conjure up anything?
Dirty sponges.
You know.
Sponges.
Yeah, there's a bunch of sponges. There's your sponges. But the truth is, you got no flow, low flow, you got excessive flow. If you're going to look at insufficient EGR flow, check to see if there's flow. Here's the real technical way you do it. You operate a fully warm engine at 2,000 RPM, measure engine vacuum, open EGR mechanically, bidirectionally, however you're going to open it, and then measure engine vacuum, and the spec says it should be lower by 6 inches. I like 8. I like vacuum to drop by 8. 6 inches seems to me like there got to be some sponges in there. You know, there got to be a little carbon in there. All right. And since I'm there, I might as well get paid for cleaning a little bit. Nobody says it's got to be a lot for me to get paid. All right. So that's the way to do it. But during warm idle operation, open the EGR and you should be erratic. I mean, on OBD1 GMs, didn't we use a green rag to test EGRs? No, it was hot, so we reached around with a rag and opened the diaphragm with 2 fingers, or maybe you had 1. Yeah, and then we expect the engine to die or run badly. Did we have flow? On a Ford, you got to suck. You know, because it's a vacuum operated one, so you're sucking down air in the hose. Or you should use your handheld pump. I kind of save my handheld pump for special occasions because I named her Monica. Right. So, how do you test for leaking EGRs? How do you test for leaking EGRs? A leaking EGR is going to be hotter than normal. Well, what's normal? An EGR that's not leaking is intake manifold temperature. An EGR that's leaking EGR gases is equal to the exhaust gases. So measure the exhaust gas and measure the intake. And you're using a Raytec gun, not a thermometer. You better go back to reading ahead. So measure the EGR temperature. Which one's it closer to? Which one is it closer to? You know? And I will tell you something. When I've done that with people, what do we want to do with leaking EGRs? We want to put a piece of cardboard in there and block EGR. And if the problem goes away, we know, no, that's a valid test. I still do it.
Pipe plug.
You know, a pipe plug for Fords. You know, I mean, yeah. So, yeah, I want to block it. But the truth is, one day I went, duh. If there's EGR flowing through, it's going to be hotter than it normally should. Raytec, I love that Raytec gun. I love that Raytec gun. And you may have a different version because you're a cheap bastard, but what? What? You know, I have these. I had the whole kit. That's the last one I got. And I've never had these. I had to go to Webb and steal that picture, you know. But we can plug it. I use cardboard. I knew a guy, George Lesniak, and he would shape the cardboard like the shape of the EGR. He'd work it. He'd do this. I go, what are you doing? I go, I used a square piece and you used something that looks like the EGR, and the test was what? The same. Shut up. EGR is best tested with TIDs and MIDs and SIDs. EGR, if you really want to know what EGR is doing, if it's passing or failing, you're going to look in mode 6. Mode 6 will tell you more than you can even dream about. If you want to, on GM and Chrysler, you can graft EGR duty cycle versus MAP or mass airflow. And here's a quick and down and dirty Ford, Chrysler and GM EGR test. The average duty cycle seems to be between 20 and 50. It's very rarely over 50 unless something's bad. It's very rarely under. So that seems to be the working duty cycle of the EGR on a Chevy and a Chrysler. If it's below 20, there's excessive flow. If it's above 50, there's enough. Meaning that here, it's below 20, it's trying to close it because it's got excessive flow. Here, it's trying to open it further because it doesn't have enough flow. Very, very accurate test in GM and Chryslers only. And on Ford, you have the what? The one that one's sensor that never breaks? So if you're going to graft MAP, it's going to look something like that. You're going to look at duty cycle. As duty cycle increases, your voltage on MAP should increase. So you can do that. But I like to look at duty cycle. It's quicker, faster, and dirtier. Now, you do know that Ford stopped putting their hoses down on that tube. That tube's gone. So they put one at the base of the EGR. Now the orifice is the EGR connected to the intake. And then the other one goes up to the intake manifold. And so when now, I don't know if you've noticed, but on newer Fords, last 3 years, the newer Fords have a PID called MAP. It's back. And that is MAP. That is MAP, right? Manifold intake, manifold absolute pressure. So it's there. So it's the same system with a DPFE that never goes bad. And then, what's wrong with DPFEs? Why do they very rarely set codes? Why do they always set low codes? That the computer's going to test the DP. If the computer's going to use the DPFE to test EGR, it's a computer. It tests the DPFE first. But there's the frickin' specs. I mean, really, you got 5 volts reference, so how much room do you have here? You got 50 millivolts, so how much room do you have?